think it'll make more sense with the examples if I'm being honest. It's a lot of notes.
Took like 4 pages.
Okay. So these say an object dropped from rest from the top of a tall building falls y equals 16 t squared feet in the first t seconds.
What?
Yeah, that's why I said yesterday this is going to sound a lot like physics. I already did physics this morning with pre-cal. All right, so find the average speed during the first 4 seconds of fall.
Put that down.
So they start us with y equals 16 t squared. It's happening in 4 seconds. So this one, we don't need to do the like t plus h and all of that because this is like during the first 4 seconds. When we get to another one in a minute where it's at a specific time, we'll have to like plug in the t plus h and all that stuff from that formula. So basically we're looking at delta y over delta t. So we're plugging in this value for t, and then so it's like the final minus the initial time. So 16 times 4 squared minus 16 times 0, and it's still squared, over 4 seconds. So I think somewhere we had this written yesterday, this formula. Where is it? Yeah, so it's basically just delta y over delta t, but if we don't know something, then we'll use this version. You'll see one of those in a minute. So then
So can you explain how you set that up again? The 0 is
the like initial, so it's like final minus initial,
gotcha.
because it's the change in y over the change of time, and we know it's during the first 4 seconds, so that's why 4 is on the bottom, and then it's at 4 seconds initially, and then, or sorry, it's 0 seconds initially, 4 seconds final, and so that's final minus initial, just plugged into this equation. So then 16 times 16 is
256.
divided by 4,
64.
so 64 feet per second. All right, this next one we're going to do the other way. So this one says, find the speed of the object at t is equal to 4 seconds. So the last one we were doing average speed. Now we want it at a specific time. So that's the instantaneous velocity. So this one is still delta y over delta t. Okay, and it's still this y equals 16t squared. For that whole like section, that's what it is. So what we're going to do is we're going back and we're using this, scroll so far. We'll be plugging in t plus h and then t and then h over like on the bottom. So the t plus h, t is the value that we're given at that specific time, okay? So that's the instantaneous speed for this one. So we have 16, and then in parentheses where t was, we're replacing that with the t plus h value, which is going to be 4 plus h, and then squared, minus 16 times 4 squared divided by h. So then we've got 16 times, this is a what? Perfect square trinomial, so that factors into 16 plus 8h plus h squared minus, that's 256, all over h. So then I've got to multiply this 16 through, so it's going to be 256 plus, was that 128? Maybe, yeah, I think so. 128h plus 16h squared. Yeah, maybe somebody check me before I go too far. Minus 256 over h. So then the 256's cancel. I can take out an h. So I'd have h times 128 plus 16h all over h. H's cancel. Now, when we want instantaneous speed, so at a specific instance, okay, we are doing the limit as h approaches 0. Of 128 plus 16h, and all that happens is we plug in 0 for h. So basically this is just going away and I'm left with 128 feet per second. Okay, and that's the instantaneous speed. So the difference in this problem and the previous one, the other one was on the average speed from 0 to 4 seconds. Okay, or it said during the first 4 seconds. This one was at a specific instant of time. Okay, so that's why we had to take the limit for this one. Yes?
So on like the second step, how did you get like the 8h? Because I know the 4 times 4 is 16, but then like the plus 8h.
Because it's plus 4h plus 4h.
Okay.
So that's just the middle of a perfect square trinomial.
Okay.
In calculus, it's the algebra that kills you. That's what everyone will tell you. By the time you get the calculus down, you'll forget how to do the algebra. It just is. It's annoying, but it is how it is. All right. In exercise 5 and 6, use the limit as x approaches c of k is equal to k, the limit as x approaches c of x is equal to c, and the properties of limits to find the limit. So let me, first of all. He put a new Bible verse up today, by the way.
I know that verse really well. My parents would make us memorize it every time we were meeting to each other.
All right, so they tell us in the instructions the limit as x approaches c of k is equal to k. The limit as x approaches c of x is equal to c. And then it just says to know the properties of limits. So problem 6 actually says the limit as x approaches c of x to the 4th minus x cubed plus 1 over x squared plus 9. So I know this is going to be really mind-blowing, But literally all we do is replace x with c. Some groundbreaking information.
No way. That's all we do.
For this one, yes. Okay, so when we do a limit, we just plug in whatever is given to us. Since this is just a letter, we don't know what like number it represents, that's why we're done. Okay? The only other time that there's going to be a problem is if whatever we plug in makes the denominator 0. Okay? That causes a problem. We'll get to that later. If that happens, typically we can either factor and cancel, so we don't have a 0 on the bottom, or we'll find out in a later chapter something completely different that happens. Okay, now we can actually get into the fun stuff. Determining the limit by substitution. Probably the easiest thing to do with limits.
Oh,
Yay. I don't know. That was
I just
pretty
heard fun
easy.
stuff
Or
and I
the
was
easiest thing
scared.
to do with limits is
yeah,
just
that,
not do the.
that was a
really
real
fast.
knee slapper, Nathan.
Yeah.
All right, the limit as x approaches -4 of x plus 3 raised to the 1,998.
Hold up, my head hurts worse.
Might be because it's kind of warm. You can turn the thingy down some if you want. I swear I haven't moved it in earlier. It was freezing.
Up or down?
No, the other way. Toward the cold. Oh, maybe not that far. That's going to be really cold. That's going to change it by like 3 degrees. We're going to be icicles if we do that.
Good though.
My problem is I sit right under the vent. That's why I feel like I'm always cold.
That makes sense.
That makes sense.
Okay. So, more groundbreaking information. We just plug in -4 for x.
What? Really? It's the most
I like
beautiful
this
thing
one.
I've ever seen.
I don't know about that. Most beautiful thing I've ever seen is definitely not that.
Maybe like
You don't think math is beautiful?
No.
When I'm not the one doing it.
Math is beautiful when it makes sense.
Yeah, so like.
All right, so -4 plus 3 is
-1.
-1.
raised to the 1,998.
1.
One.
1. Thank you.
It's
It
did take me
a
like.
minute.
Okay?
Had to
Because
make sure if it was negative or not.
I hope you know that's an even number, so it had to be
Well,
positive.
it took me a second to discover.
All right. We'll get a little bit more difficult than that. That one was a little
You
easy.
do not deserve his love. You abuse
All right.
him.
The limit as y approaches 2 of y squared plus 5y plus 6 divided by y plus 2.
Guys, I think I know what to do here.
You want to share?
Yeah, do you want to share? Because I'm really
Share.
stumped.
Now I know this is a hard. I know this is a hard one, but I think we need to substitute the 2 for the y's.
We do.
I like your reasoning, Josh.
Can you prove that statement?
Trust me, bro.
I thought you were
Trust me, bro.
Trust me, bro.
Just trust me, bro.
Oh my god.
Quote of the year. Just trust me, bro.
That should be your like senior quote.
That could be your senior year in 4 words.
Just trust,
Just trust
me,
me,
bro.
All right.
That's what God said to Adam.
Jeez.
All right.
Bible.
2 squared is 4, plus 10 is 14, plus 6 is 20,
I made this one.
over 4.
Like it's
Me
fine.
too. I just wrote
I
like
just
every
wrote
single
out, like,
step
every
of
single
the
step.
algebra.
Yeah, you don't have to show it all. I
yeah,
just.
I just don't. I
Wait,
just,
how would you guys?
But because it's the algebra that kills you, I usually do.
yeah. What'd you say?
How would you describe your senior year?
Well, it's barely started, so
Let me out, Mom.
what?
Let me out. No, I was thinking of 4 words and putting them together. I was thinking let me out, but I didn't know what to follow it. It wasn't that funny.
Every fetus. Bruh, okay.
Okay, back to
I
math.
don't think they want to leave. It's
Back
nice in
to
there.
math.
Yeah. Yes, please. The one time I want to go back to that.
Why is this weird of lady?
All right. Explain why you cannot use substitution to determine the limit. Find the limit if it exists. $22. The limit as x approaches 0, y'all are freaking me out, of 1 over x squared.
So we plug in 0 for x.
Wait, but that's like
But
You
then
can't
give us a
undefined.
That would give us a
undefined.
You
Not
can't
fine.
do that.
Okay?
So there's no
Because it
nothing
is not
else.
defined at x equals 0.
Yes.
Undefined.
Look at us.
Undefined.
Not
Fine.
fine.
Ah.
At X equals 0.
So there's no limit.
That works.
And there's nothing that can cancel. That would be the only other way we could potentially have a limit still, is if we could cancel. But they're initially asking why substitution doesn't work. Okay. Which probably like 90% of the time is because the denominator would be 0. 24. The limit as x approaches 0 of 4 plus x squared minus 16 all over x. I guess I should have written no limit. What's the problem with this one?
The x cannot be something with x equal 0.
Yeah.
Not defined
But
at
the
x
final
equals
thing
0.
would be 0 over 0, which is the 0.
What?
I was
Well,
thinking that too, Nick.
Yeah, because if you plugged in the x on the top, or that would just be 4 squared, which is 16. 16 minus 16 is 0.
So,
It would be 0 over 0, which is just 0.
right. But I am going to tell you this one does have a limit. We just can't do it by substitution.
I like substitution though.
Yeah, I know. It's the nicest method. All right, so what we do is we're going to factor this out and see if anything can cancel. Okay? So if you weren't sure, if I didn't just tell you that it is going to have a limit, you would just have to check. But I just told you that it is, so we're going to actually do it. So what does this factor into?
16 plus 8x plus x squared.
Then minus 16 and then over x. So 16's cancel. I can factor out an x. So that leaves me with 8 plus x over x.
The limit is 8.
X's cancel. Okay, and technically, in technicality, you should every time be writing the limit as x approaches 0. Okay. I typically just wait and write it at the end just because I get tired of writing it 80 million times. But the limit as x approaches 0 of 8 plus x is equal to 8. Okay. So that's why I said sometimes you can factor, cancel things out, and it will get you to a limit. It just wasn't done by substitution initially. It's not that it's not ultimately getting substituted in. So always check that, as you go.
Yeah.
So these ones say to determine the limit graphically, confirm algebraically. Basically, you would have to graph it in your calculator and then look at what's happening to it and make a decision about it. My opinion is that you know how to look at a calculator graph, so we just do it algebraically. Okay.
Bold assumption.
Well, if you don't, then I would suggest you work on that. All right, so 26, the limit as t approaches 2 of t squared minus 3t plus 2 divided by t squared minus 4. All I see is him petting a pencil out of my peripheral vision.
Josh wanted to take
What is it?
I asked for the pencil,
Just
and he
one.
was like,
it.
He
No, I
said just
no,
wanted
it's
to take
mine.
All right, so can I substitute?
yeah, no.
Well, it'll be
Well,
the
it's
zero.
not defined by
It'll be a
zero.
zero.
If the denominator is 0, the answer is no. I cannot substitute. So, any suggestions on what I maybe can do instead?
Like, I guess,
And like
you know, whatever you want to.
factor.
Factor. Okay, so what does the top factor into?
You know.
Josh, we don't know. That's why she's.
Oh, I got
either.
this.
Factors of 2 that equal negative 3.
Right.
Wanted.
Thank you.
Dang.
I'm telling you, it's the algebra that kills you.
I love
People
that.
don't believe me. What about the bottom?
We trust
It's a special type.
Oh, you know.
Obviously, it's
The perfect
It's
square. No.
It's a different.
t minus.
Difference of squares.
Yeah, so t minus 2.
And
Plus
T
2.
t plus 2.
all right, now this is more groundbreaking information. Top and bottom cancels.
Oh my goodness.
That's crazy.
Illegal.
So now I have the limit as t approaches 2 of t minus 1 over t plus 2. Now can I substitute?
Oh my goodness, yes, you can.
Yeah.
Hallelujah. T minus 1 over t plus 2. 1 over 4.
Yeah.
Oh my goodness. that
Some
makes
crazy
sense.
information right there.
You need to chill out, Nathan.
Like,
Like, oh my goodness.
Like-
Crazy. Oh my goodness. Terrifying me.
Hey, somebody's got to make calculus interesting.
Amen.
I don't know. I'd rather it be not interesting.
You'd rather be falling asleep while I teach it?
Yeah.
Because I can arrange that, but I don't think that's going to be very fun.
I don't think I've ever fallen asleep.
They're
in
just
class.
okay. Sometimes
Actually
it,
not true.
sometimes
I-
it can just
I've
get
only
too
Bible class.
interesting.
I definitely fell asleep in your class, like this year.
Yes, that's it. You literally,
Because
yeah.
We had
I
a
know.
designated nap time for that.
I don't think we had a designated nap time. I think we had a work day and you took a nap.
I thought it was
There's-
free time.
Well, that's probably,
I was like
probably a
slumped
work
over
day.
with the pencil.
You were pretty.
It was very funny.
Brooke used to nap in here all the time.
I know.
I
understand
can't
why.
nap if I'm not at my house. It's just
It was not a
funny.
pretty sight when Melcher woke her up one time.
Mm.
It was kind of scary, I'm
She
not gonna
slapped.
lie. She threw a cow at him.
No.
Very hard.
Oh, good for her.
He threw it at her first, but
Oh, okay. Then yeah, it's fine.
One of those cows?
I think it was Gerald.
You're looking
All right. Any recommendations on this one?
So I would recommend you to.
I'd recommend not to do it
Haha, so funny.
because there's no limit.
Should,
So I would actually recommend doing.
well, okay.
Can I substitute?
No.
No.
Mm-mm.
Okay.
So I would recommend not substituting.
Good job.
Good job.
Do we want to make the denominators at on the top the same or no?
That would be a good idea.
I was really hoping it would be able
It's a
to.
really good recommendation. Keep it.
So I'm going to multiply by 2 over 2 and 2 plus x over 2 plus x.
I mean, I like good ideas now.
So the limit as x approaches 0 of, and I can write this all as 1, so 2 minus x over, debating if I want to go ahead and I'm gonna go ahead and multiply it. 4 plus 2x all over x. All right, so the 2's on top cancel. They just give you 0. Now, anybody know what I need to do?
Ooh.
Pretend the limit's not there.
Ooh. I know. We could like multiply by the bottom or something like.
How?
Switcheroo thing. Maybe like
Sort of.
like.
Dividing is the same as multiplying by.
yeah.
Reciprocal. Keep change rule.
Well, sort of. Dividing by something is the same as multiplying by 1 over that.
Oh yeah. That's what I
So
was trying to-
kind of what you're saying, but not exactly what I was going for. But yes. So the limit as x approaches 0 of negative x over 4 plus 2x times 1 over x. At this point, still an issue because I still have an x on the bottom. That's going to make that undefined. But x and x cancel. So I'm left with the limit as x approaches 0 of negative 1 over 4 plus 2x. Disappeared.
Guess what? We can put the substitute it now.
And I get
Negative 1/4.
1 over 4.
yep. All right, we're gonna jump down a little bit. I will probably come back to 30 tomorrow. TBD. We might do it before the end of class, but I'm skipping it shortly for the moment. Because I would rather get through the other stuff and then go back to that because it's pretty different. All right, 32. The limit as x approaches 0 of x plus sine of x over x.
Well, sine of x over x equals 1, right?
Okay.
But we have to do something else first.
Well, you're on the right track.
Okay.
Okay. So, I obviously can't initially plug in 0 because we have 0 on the bottom. But I have a common denominator, so what can I do?
Split up and factor.
Split it. So I'm going to split it into 2 separate limits. So I'm going to have the limit as x approaches 0 of, and I'm just going to show out this entire step so that you see it, of x over x, obviously you can rewrite that as 1, plus the limit as x approaches 0 of sine of x over x. Now we know that x over x cancels to 1. The limit of a constant number is just the constant number, so that's going to be 1 plus, this was the limit that I gave you yesterday that Peyton reminded us is 1. And so that is equal to 2.
Wow. This is the most complex way I've ever seen.
1 plus 1 equals 2. Funny.
Some of the things on the clock may start to make more sense this year.
Well, I knew a lot of them last year.
Or on the calendar behind Nathan's head.
Wait, there's a glitter on the clock.
Oh, I know how to do the 3 exclamation point thing.
Oh, I thought it was gonna be an epilepsy.
Epilepsy.
Epsilon?
Yes.
How are you supposed to put anything on the calendar?
You don't. It's just still math all day, every day.
Oh, so like the date is the answer to the math?
Wait, really?
I don't.
Most of the time, not all the time.
Oh. I don't think
Most of the time it is, but sometimes on like a special day like pi, the answer will likely come out to be pi.
Oh.
Like on March
So
14th.
it's not like it's not just giving you like random problems to do every day.
Well, it is, but
Like
you would only know what the answer was if it was equal to the date.
Got it.
All right, 34. The limit as x approaches 5 of x cubed minus 125 over x minus 5.
Wow, guess we can't substitute.
I can't substitute. What might I do instead?
I would recommend taking the cube root.
We can,
Do that.
Can't do that.
can we split them up?
I would
What is this?
minus.
My minus sign. Oh, it's
Subtract.
difference of
Difference of cubes.
Yes, thank you.
Oh.
Well, you pointed to right to the subtraction sign.
It is a difference of cubes.
one.
Okay.
I'm so proud of myself.
So, what does that factor into then?
Cube
Oh, wait.
root of.
No.
Doesn't matter.
I'll give you a hint. It looks like this.
Right, because it's
That one's so much bigger than that.
x
X
minus 5.
Okay, there we go. Making progress.
Then
X. Yes,
X squared plus 5x plus 25.
Yes, sir.
Like you do.
yeah, like,
Yeah, okay.
you didn't know you were there.
So, that's a difference of cubes. Remember, that's SOAP. Same sign, opposite sign, always positive.
Oh, is that how you do them? So,
Yep.
same sign, opposite sign.
Over x minus 5. So then, x minus 5 is gone. So now I have the limit as x approaches 5 of x squared plus 5x plus 25.
Now I can do it.
So that's 25 plus 25 plus 25, which is
Is it
75.
These seemed a lot more difficult last year. When we did them at like that last chapter.
We did the harder method.
Oh, that makes sense. Wait, so do we not have to do the harder math question?
We will. Because it does different things.
Where is that?
Ask for the.
5 minutes.
Okay. I'm going to go ahead and show you 30 because we have time. I just don't want to spend time doing it if we were going to run out for the other stuff. The limit as x approaches 0 of sine of 2x over x.
Bless you.
All right, now
Here's the
there's a couple ways you can look at this. We didn't do a lot with double angles in the past, okay? But we are going to kind of need them for some things like this. So, I can rewrite the sine of 2x, just bear with me, I promise, as 2 sine of x cosine of x over x. Okay. I know what the limit as x approaches 0 of sine of x over x is.
Yes.
Okay. So, I can split that off into its own, multiplied by the limit of 2 cosine x. Okay. So, I'm going to turn this into the limit as x approaches 0 of the sine of x over x times the limit as x approaches 0 of 2 cosine x. Okay, do we follow how I split that so far?
Yeah.
Minus the fact that you might not have remembered the double angle.
I didn't know.
Yeah. I don't remember.
I would say you probably should at some point memorize the double angles, okay, for at least sine and cosine. So sine of 2x and cosine of 2x, because there will be times that they are useful in things that we do. So we already know what this limit is. Yes?
Hey, question for you.
Yes. You're good. Yes, I figure we would do kind of like the same design for the whole year. And then we'll just like change for like each sport individually. Unless basketball decides they want to do something like a different design, I would just roll with that for like the whole year for all sports. Yep.
Right.
Oh gosh. Okay. Times. All right. If I were to plug in 0 for x, what is the cosine of 0?
Cosine is
Wait, give me a second.
Think of it as the cosine of 0 degrees so you don't get confused.
Wait, wait.
What is the x value? 1. Okay.
So-
So 1 times 2.
Is
So 2 times 1. Okay, because this part right here individually is 1. 2 times 1 is 2. And there you go.
Can you explain that again?
The 2 times 1.
The 2 times 1?
Oh, no, I know that.
I was like,
just trying to
it's
remember.
like, man, it really is the algebra. So I rewrote it. I split it into 2 separate things. So I had the sine of x over x and then 2 cosine of x. I know what the sine of x over x for the limit of as x approaches 0 is. I know that's 1. So then the other one, I replaced 0. I did substitution. So I put in 0. Cosine of 0 is 1
Oh, okay,
times 2.
substitution.
And then that.
Got it.
All right, your problems are. Oh, we're done with this chapter or this section. 1, 3, 5, 9, 25, 27, 33, 43, 45, and 47. Oh, wait. Nah, we need to go over. You can't do 43, 45, and 47 yet. We'll look at those tomorrow. We need to go over one.
Okay.
We'll just talk through one tomorrow at the beginning. And then we are going to do the notes for the next section tomorrow. And then after we do the notes, we probably will have time you can work on this stuff. So you don't have to do it tonight.